Welcome back to Sparsh. Today we are going to check the problem number 2574 of LeetCode. This is a pretty easy problem. Let's just quickly get through the problem. So the problem name is left and right sum differences. Now here we are given a zero index array of nums of size n, and we need to define two more arrays. One is left sum and another is right sum, where left sum is the sum of elements of elements which are like starting from index 0 until index n. So it is nothing and is just a prefix sum of an array. And right sum is the sum of elements of the right of the index I on the array. In that, like, that means that the array is starting from the rightmost element and is going till 0. So this is nothing but just a postfix sum. Now what we need to return an integer array answer of size n, where answer I equal to left sum I minus right sum I ka mod. If you will see this, so what does mod means? Mod means ABS of left sum I minus right sum I. So this is a pretty straightforward problem. Anyone can get the intuitive approach. We'll just go through one example. So let's say array given to us is 10, 4, 8, 3. Now let's calculate the prefix sum of this array. So prefix sum will be 10, 14, 22 and then 25. And similarly, if we want to calculate the postfix sum, we'll write it like 3, 11, 15, 25. So in prefix sum and postfix sum, you know that the sum of the array is contiguous. Like here the array sum is increasing like this, here the array sum is increasing like this. So the element 0 in postfix sum array and the element last in prefix sum array is always equal because it is the total sum of the array. So now the answer. So answer I, what is written to you? Left sum I minus right sum I, and left sum is prefix sum and right sum is postfix sum. So 10 minus 25 is minus 15, but we are taking mod of it. So it is 15, 14 minus 15 is minus 1. So it is 1. 22 minus 11 is 11. And 25 minus 3 is 22. So this is the answer array which is equal to what is given to us. So now this is pretty straightforward. Now constraints are given to us that num's length can range from 1 to 1000. So this array can also increase till 1000 elements. And each element can range from 1 to 10 raised to 5. So each element can be till 10 raised to 5. So if we try to calculate that, let's say if the array of length, nums dot length is given to us as 1000 and all the elements inside it are 10 raised to 5, then even though the sum will come which is equal to 10 raised to 5 into 10 raised to 3, which is equal to 10 raised to 8. So what this means, that this 10 is like it can be accommodated inside an integer variable. So now let's move to the solution 1. Like solution 1 is basically what is the brute force approach. We have taken n as nums dot size and we have taken 3 arrays: prefix sum, postfix sums and answer. Now prefix sum, we have initialized prefix sum with num 0 and we have initialized postfix sum as nums dot back. Nums dot back is nothing but the last element of the array. Now we have pre-computed the prefix sum array here, like for I equal to 1 to I less than n, I plus plus, and similarly we have computed the postfix sum and that we have computed through reverse. So postfix sum I plus 1 plus nums I, and to compute the answer, how we did here is we just have taken absolute of prefix sum I minus postfix sum I and we have returned the answer. So now what do you think is the time complexity and space complexity of this like brute force approach? So O(n) will be the time complexity because you are seeing that for loop, this is running n times, this is also running n times, and this is also running n times. So n plus n is 3n, and we can say it is having a time complexity of O of n. Similarly, if we want to ask what is the space complexity, so we can see we have declared one variable n and prefix sum, postfix sum, and answer. Now answer is the array which we need to return. So we will not be counting this array in our space complexity, but still we can see O of n, this is n, this is also n, and this is 1. So O of n plus n plus O of 1 is also O of n. So time complexity and space complexity are both O of n. Now just to make this solution more elegant, what we can do is we can move here, and here we also have the same thing, n prefix sum, postfix sum, answer. The prefix sum num0 and postfix sum as nums.back. But here one thing we did was we just removed this second for loop which we had in the previous solution. So now prefix sum and postfix sum is what we are calculating inside a single loop. Now one thing which we need to note here is this is not at all an optimization. And why is it so? Someone might say that we are using two loops here, but here we are using a single loop only. So why is it here? You can see that a total of n operations are performed in here and a total of n operations are performed in here. So total operations which are performed are 2 into n. Now if you see here this line number 9 is performing n operations and line number 10 is also performing n operations. So again the count of operations which is being performed is 2 into n only, and hence we will be just this is not an optimization. And coming to the answer part is exactly the same. So again time complexity just remains O of n and space complexity also remains O of n. Now let's move to a better approach. Let's say in an interview, the interviewer can ask you that okay, let's say your time complexity is O of n, but can we reduce down onto the space complexity part? So what we can do here is we can take nums.size as n only, but now postfix sums, instead of maintaining an array for postfix sum, we are now storing it as a variable. And now we also checked at the start that the variable the sum can go up to 10 raised to 8. So the postfix sum can also come inside this int variable, like how it was coming inside this vector int. Now we have prefix sum n and answer n. So now what we did is we are now only computing prefix sum, and we now have the whole array of prefix sum, and then we run a for loop where we are now at every point in time we are traversing from reverse. Let's say this is an array, we are traversing from here and going here. So for every point we are calculating the postfix sum. So at n minus 1 we now has the postfix sum equal to this last element itself, and then the answer of I is what? Prefix sum I minus postfix sum. So answer of n minus 1 was prefix sum I, which we already computed here, and the postfix sum is we computed at this line. Similarly, let's say if we go to here, postfix sum I equal to postfix sum I plus 1, their value which is in forward of that postfix I. Let's say this is n minus 1, this is n minus 2 then. So for this position the sum is postfix n minus 2 plus 1, and hence n minus 1 plus nums of I, and hence we are having a postfix sum I again. So what we get here is that the answer will be prefix sum I and minus postfix sum I, which is exactly the same. We just now have reduced on to some of the operations. So now here you can see that the number of operations performed is being O of n in this first for loop, and in this second for loop we are computing postfix sum as O of n and this answer I again O of n. So total number of operations still remain the same, which is O of 3n, and this gives you the time complexity of O of 3n which we can say as O of n, which is similar in all the above two cases. But if you see the space complexity part, earlier we were having two arrays, prefix sum as well as postfix sums. But now here we are not having two arrays, we are having only prefix sum as an array, and for postfix sum
It's
we are just
11
maintaining
AM.
it inside a variable. So now the space complexity, although it remains same because prefix sum takes space complexity of O(n), but postfix sum is now O1. So space complexity is also now O(n). Let's say now interviewer asks you to, interviewer already asked you to optimize the solution in terms of space complexity, keeping time complexity constant. So now what we can do? We can now even remove this prefix sum array, because what you are seeing here is prefix sum is nothing, just we are computing all of the sum of the array, like pre-computation is being done here, and then what the answer I is doing, answer I is also running on a similar loop, and then it is just using the prefix sum I value which we have pre-computed before, like on line number 7 to 9. So what we can do is we will drop the prefix sum I value in as well. So now you will see we have only nums.size, postfix sum, and then array answer, and this is expected to return. So we don't count this as a space complexity which we are using, because this is anyhow we have to use. This is not anything additional which we are using to pre-compute, to compute the sum. So now here what we are doing on line number 7, if you'll see, we are using the same array answer I to pre-compute the sum first of all in answer I. So answer I is basically nums I, let's say for num0, we have declared it here, num0 is equal to prefix sum of 0, which is nothing, just sum equal to this value. Now prefix sum 1 is again will point to nums1 plus num0. So this is exactly how we are computing prefix sum here, and that is also we are computing here. Now instead of storing it in prefix sum, we have stored it in answer I. Now postfix sum is also what we have seen here, how we are computing this postfix sum plus equal to nums I. We are doing the exact same thing here also. Now coming to the answer I part, what we were doing earlier was we were doing ABS of prefix sum I minus postfix sum I. Prefix sum I is the sum of the elements till point I. So this is an array, and let's say this is the value we are at. So prefix sum is the sum of all these values till we are at I. Now answer I also contains now the same thing itself. So answer I is the sum of all those elements which are till I only. Here only the sum, this contains the sum itself. So answer I is nothing, just prefix sum I minus postfix sum I is what we have computed just now. So in this case what we'll see is time complexity will remain the same, because we are doing O of n here and O of n here as well. And if you want to see the operations still remain same. O of n in the first loop, and then O of n plus O(n) of n in second loop. So time complexity is O of 3n equal to O of n itself. But if we not talk about space complexity is that we are not using any additional space. This answer n is what we are returning itself, and we are not using any additional space to even show this answer, and hence the space complexity will come to O of 1, and hence we have now reduced the time TC to O(n) and space complexity to O1. For more of this weekend series solution, please like, subscribe and follow to my channel. Thank you.